I'm just going to write this down. This one, and we proved this in our last lesson, but opposite sides of a parallelogram are congruent. So like the top and the bottom, these two guys are equal. The left and the right, these two guys are equal automatically. We proved that, like I said, in our last lesson. So we're going to do that. The other one, this is consecutive, which meaning right next to each other, consecutive angles are supplementary, meaning they add up to 180. Okay, now in the very first question, you don't really have a choice. Like I can set the left side and the right side equal, so I'd have x equals 2y. I got an equation with two variables, very similar to that homework problem we went over. Okay, same thing, top and bottom, if I set these equal, 5x minus 3 equals 3y plus 4. Again, I've got two equations, and each of them have two different variables. Anybody have any idea, like, how would I go about, if I have two equations and two variables, you can solve for them. Does anybody know what you might do as your next step once you set that up? Yeah. Exactly. Perfect. Perfect. Exactly right. Okay. So we can just do a little substitution. We have x by itself. So I can take this, and everywhere I see an x in the second equation, we'll just replace it with that expression, and I'll be really careful with it this time. All right, so I have 5. Instead of x, I'm just going to plug in what x equals, which is 2y. And don't forget the minus 3. When you do that, that creates just one equation, and we only have the variable y. So once we set that up, we'll just do this real quick. This will be 10y minus 3. 3y plus 4. Okay, who could tell me if you were solving that, like what would you do next? Because there's different ways you could do this. I'm just curious. Subtract 3y. All right, so I got 7y minus 3 equals 4. What do you want to do after that? Plus 3. Okay. If you did it a different way, that's totally fine. There's different ways you can do this. So I get 7y equals 7. So what's my y going to equal? 1. All right, now, how would you find x? Because I have two variables in this problem. If I know y is 1, how could I find x? Plug it back in, exactly. All right, so I would just come right back up here. Now we know what y is. So x is 2 times y. I'm using a lot of room here. X equals 2 times y, which we know is 1. So x is just going to be 2. And that's all we have to do. If it were to ask you to go back and tell me, like, what are the lengths of the sides, you could plug the variables in to figure that out. But it just asks us to solve for x and y there. Okay. Now, the question right next to this, you have angles marked, not sides. These are angles. The angles right next to each other have to add up to 180. Now, you could set up a system here. So, but what I would recommend, if you use this angle and this angle, these are consecutive angles, meaning they're right next to each other. Let me kind of, like, we'll throw back to when you guys were working with parallel lines and transversals. To form those two angles I just highlighted, I would use the left side and the right side. Those are the two parallel lines. And I could use the bottom. That would be my transversal. These are just two angles that are on the same side of that transversal in between that two parallel lines. If it helps you, sometimes people like to turn it, like they just like the parallel lines on the top and bottom of the figure. You can turn it, but those two angles would add up to 180. And what I would tell you right there, that's only got one variable. So the 4y plus the 5y has to add up to 180. Because they're going to be same side interior consecutive angles inside that parallelogram. All right, so just add these guys up. You got 9y equals 180. Anybody know what y would be? This is a nice number. 20, yeah. Okay. Now, my equation didn't involve x at all, but if I knew this was 20, we could go ahead and put it back into the picture to figure out the actual angle measures, like right here and right here. So if I do 4 times 20, that would make that angle 80 degrees. If I did 5 times 20, that would make that angle 100 degrees, which those add up to 180. How would you guys go about figuring out x? Does anybody know where that expression is, right? The 5x plus 25. Does anybody know what that angle would measure? Exactly. This, because you guys know these consecutive angles add up to 180, this angle has to be 100 degrees. So that way the 80 and the 100 would add up to 180. So to find x there, actually what I would just do, if you can figure out that angle measure, then we can just set that expression equal to that angle measure, and it's not that bad. So I'm going to subtract the 25 here. All right, so I get 5x is 75. Does anybody know what that is? I think it's 15. I'm going to check on my calculator just in case. I'm pretty sure. Yes. Okay, there we go. 15. So there's different ways you could do these problems. That first one we had to do a system. You might not have to do that with like the one like the second one. It's just going to kind of depend on the question. Is anybody having a question? So those were the two properties we talked about in our last lesson. I'm going to give you a new property today. So if you have a parallelogram, and remember, this is a theorem, so we have to prove it before we can use it. It's not just an accepted statement of fact. So once I prove it, though, you're going to actually use this in some problems today. But what's going to happen in this one is we're going to look at the diagonals. And remember, a diagonal just connects two vertices that are not next to each other. So I've got two different diagonals in here. And what this theorem is going to say, which we're going to prove in a second, if a figure is a parallelogram, so if I know that, then the diagonals bisect each other. Does anybody remember, what does the word bisect mean to you? Split it in half, exactly. Okay, so basically what goes on here, where these two guys intersect, they cut each other into two equal pieces. And you'll notice they're marked, let me make up a number real quick. I don't know, I'm just going to make something up. Like let's say this piece is 5 and this piece is 5. They're not necessarily the exact same, right? Because you can tell if you look at that diagram from D to B, that is a longer, if we were to get a ruler out, that's longer than that diagonal from A to C. So they're not all the same length, but they run into each other. Let me write a little M on this. And the reason I'm choosing to write the letter M is because that would be the midpoint of both of those segments. So I'm just going to write you a little thing. If I took the segment from A to M, that midpoint, it would be congruent to the segment C to M. Similar argument. The segment from D to M would be congruent to the segment from B to M. And you'll see the diagonals, they bisect each other. The key to that, though, too, is they're going to share the same midpoint. We're going to use that a little bit more in the homework assignment today. But let me prove this theorem to you really quick, and you guys can kind of see my picture. Let me color my picture real quick. We're going to look at these two triangles. You're going to see some numbers in here just so I could label the angles without using all the letters, because I got a bunch of different lines going on here, but I'm going to focus on these two triangles in this proof. But this is supposed to be a parallelogram, right? This is given ABCD is a parallelogram, so overall the figure is a parallelogram. That means, by definition, both pairs of opposite sides are parallel. That's the definition of a parallelogram. So in my justification, it's just restating that, so I'm just going to say that's given. Okay, now I'm going to highlight some lines to see if you can tell me why this is true. So I'm talking about angle 1, which is right here, and angle 4, which is right here. So let me draw the lines that form those angles real quick. So be the left side and the right side, and then this diagonal here. I know that opposite sides are parallel, so I got parallel lines here. Does anybody know what the justification would be for why those two angles are congruent? The triangles are congruent, but I haven't proved that yet. So how do I know just those angles are congruent? That's where we're going with this, but how do I know those angles are congruent? Do what? Not corresponding, you're on the right track. Different type of angles. alternate, see how they're on opposite sides of the transversal? Here, let me turn it this way. Sometimes that's easier. So they're in between the two parallel lines, but on opposite sides of the transversal. These are called alternate interior angles. Okay, now, I'm going to have the exact same argument, but I'm going to show you why. If I do angle 2, here's angle 2, and here's angle 3. Now, angle 2, part of the angle is formed by that side I just highlighted, but I'm using the other diagonal to create those two angles. So angle 2 and angle 3, we're using the left side and the right side, but we're using the other diagonal there. All right, now, same exact argument. Those are alternate interior angles. They're just using a different diagonal to form the angle. All right, now, this also says AB, which is over here, and DC, right here. Those guys are congruent. This is what we talked about on Friday. We know that opposite sides in a parallelogram, those are congruent. And I'm just going to draw one of them separate because I've got drawings all over this. So here's what I have in the picture. I have an angle. I have the opposite side. So I'm just going to kind of take this out so you guys can see it a little bit better. Can anybody tell me why those two triangles are congruent? Like, what would your defense of that be? Angle, side, angle, for sure. All right, now, because of that, we didn't know this, but now we do. Anytime you have those triangles congruent, all the corresponding parts automatically become congruent. So A to E would be right here, and that would correspond to CE. Those two have to be congruent. This is going to be the same argument, so I'm just going to kind of write a big letter here. But B to E, so I'm going to put 1, 2, 3, and D to E, 1, 2, 3. Those now have to be congruent. This is corresponding parts of congruent triangles are congruent. Same argument for both. We proved the triangle is congruent, forces all their parts to be congruent. And then what you have is those two segments cutting each other into two equal pieces. So it says A, C, and BD bisect each other at point E. Point E would be your midpoint. This is just definition of a bisector. Creates two equal pieces in between. So now that we know that, we're going to actually use it to do some problems. All right, so here's what this says. AB is 13. Let me grab a little color here. So this little piece right here is 13. What would the length of the entire diagonal be if I know that this is a parallelogram? How'd you get that? Exactly. This is right in the middle, so this piece would also have to be 13. All right, along the same diagonal, if you get to the middle there, it's going to cut it into two equal pieces, so the whole thing there would be 26, just 13 and 13. All right, now this is a little bit backwards. So this is going to give me the length of the entire diagonal here. So that whole thing is 36. That's not a good way to illustrate that. But I'm talking about that whole diagonal. The length of that is supposed to be 36. Then it wants just the length from B to E. How could I figure that out? If I know the whole thing's 36, like how would you figure out from E to B? To cut it in half. The whole thing, 36 divided by 2, 18, because you know that those diagonals intersect to cut each other into two equal pieces. So this piece would be 18, this piece would also be 18. They got to be the same on either side. Is anybody having a question? Okay. Now we're going to do one more. This one's a little bit trickier. And then don't freak out when you see the diagram on the back, because that theorem down at the bottom looks really complicated, but I promise it's not. Okay. So I have two diagonals drawn in here, and they have the segments labeled in here inside the diagram. Okay, now I know that the diagonals bisect each other. So I know like this piece and this piece would be equal, and I know from K to A there in M to A's in the middle, those pieces would be equal. So I'm just going to copy the expressions. We'll just set up a little equation. So where I have X that's equal to the 7y minus 16. And then I've got the 2x plus 5. And that piece, because these diagonals bisect each other, has to be equal to 5y. Now, unfortunately, we've seen a couple questions like this today. This is a system. Does anybody know, because both equations have two different variables, so I can't get one variable, or I can't solve for either of the variables without having the other. Anybody know what you would do with this as your next step? So we've got x equals 7y minus 16. Can't solve that. 2x plus 5 equals 5y. How can I go about trying to solve this? Any idea? What do you think? Perfect, perfect. You have x by itself. We're just going to use a little substitution. So you're just going to take this, and everywhere you see an x, you're going to replace it with that expression. All right, so I'm going to put 2. Now, this is really important. If you got two pieces, right, this is like a 7y minus 16. There's two terms there. You want to put parentheses, because if I have 2 times x, I have to do 2 times that whole thing. So if you got a couple terms like you do here, or I just usually use parentheses anyway, and then don't forget the plus 5 equals 5y. Now we have one equation that only has the letter y. So I'm just going to do a little tiny distributive property here. We get 14y, 2 times negative 16 is negative 32 plus the 5. And just before I do anything to both sides of the equation, I'm going to combine like terms. So I have a negative 32 and then a positive 5. You add those guys up, you get negative 27. All right. What would you do as your next step? I've got 14y minus 27 equals 5y. I got y's on both sides. And you want to do minus 5? All right. We totally can do that. All right, so that'll give me 9y minus 27. What would that leave us on the other side? Tricky. What is 5y minus 5y? Nothing. Totally fine. Okay, now I would just move the 27 real quick. Add 27. That's so if I cancel that 5y out, totally fine, but then you don't literally you're left with nothing on that other side. So you got to write that down. So that's 0. Then we'll just move the 27 and we'll get 9y equals positive 27. Does anybody know what y is going to be there? 3. Perfect. Okay, now all we got to do, once we know that, we're just come right back up here, and we can just plug it in. And you can plug it, oh, I'm not on the screen, forgive. Okay, now you can plug it into either equation there, but I would tell you it's probably a little bit easier to plug it into the first one because you're trying to find x, and that equation has x by itself, bless you. So x is 7y, which y is 3, minus 16. So what is that, 21 minus 16? So x is just going to be 5. And once we have that, then we've got both variables. It doesn't tell you to go back and plug anything in. It just says find the values of x and y. And we can set that all up because we know the diagonals bisect each other. All right, does anybody have a question? All right. Now, this looks extremely complicated. These diagrams look crazy, but I promise this is not hard at all. All right, this says if 3, or we could have more. If you look down to the bottom of the page, like this has a ton of parallel lines in this picture at the bottom. But the requirement for this is if you have 3 or more lines that are parallel to each other, and they cut off congruent segments on one, what I'm going to write in here is transversal. And a transversal is literally just a line that runs into other lines. So in this case, I have 3 parallel lines here, and then one transversal I could go right down this side. All right, so it says if it cuts off congruent segments. If you look along here, they're marking like AC is congruent to CE. So they're cutting off congruent segments. That's what that says. Then the rest of the theorem says they cut off congruent segments on any transversal. So if you're looking at that lovely diagram there, I have another transversal, this one here. Okay, now, not necessarily the same length, and you'll see in some of these questions this is different, but if I go on that one, like B to D and D to F would be the same length. Not necessarily the same as the other transversal, but if parallel lines cut off congruent segments, then all the way down any transversal you're going to have congruent segments there. So in my diagram, BD is congruent to that DF. And basically the picture to the side there is just showing the same thing I just marked on that picture. Alright, so I promise this is not hard. We're going to come down to this diagram. So these lines, it's just going to tell you in the problem that these lines are all parallel to each other. Alright, on this diagonal here, or sorry, transversal, this transversal, you can see that each of these segments is 2. Alright, so any other transversal, so this one here, will also cut off congruent segments, but on this one, you can see that distance is 2.5. So then here, like along this same transversal between F to G, that would be 2.5. Between G to H, that would be 2.5. They'll be the same exact distance. And then the question's just going to ask you, like, okay, tell me the length of some of these segments. So just go, if you wrote it in, just go back to the diagram. So F to G, 2.5. G to H, just wrote that in there, that'd be 2.5. Now, E to H. So here's E, here's H. What would the length of that segment be? Or how could I figure it out? I feel like somebody just said it. 7.5. 2.5, 2.5 is 5, another 2.5. It's just adding all those together. This is 7.5. It's not bad. I would just encourage you, just draw on the picture. It'll make it so much easier. Okay, now, this one has a bunch of parallel lines. So there's a ton of parallel lines. It's showing you they cut off all congruent segments here. Now, it says A to E. Let me figure out where that's at in the diagram here. Okay, so let me grab a different color. Alright, so I'm going to go down this transversal right here. It says A to E is 9. So let me just, A to E is 9. So all the way down, any segment on that transversal, so E to J would be 9, J to N would be 9, N to S. I'm just going all the way down there. Those are all 9. Along the same transversal, they're going to cut off the exact same number. Alright, the other information is they tell us the distance from B to F, which is over on this one. B to F is 7. Alright, so let me go down this line. Each one of these, B to F is 7, F to K, K to N, N to R, R to W. Those are all 7. Alright, once you mark that, we're just going to go back and we're just going to answer the questions here. So B to N, what would the length from B down to N be? You got 7, 7, 7, 21. Alright. Let me see. Where is N? Here's N to X right here. What would the length of that segment be? 18. 9 and 9 is 18. Okay. Now, I'm not going to have marks on these other two sides I'm going to talk to you about, but I think you could argue to me how you know the length of them. So, X to L is here. Anybody know what that would be? It's 21. How do you know that? They are parallel, yes. These are parallel. This guy, like right here, is a parallelogram. Like right in here. This whole thing is a parallelogram. You're going to know, right, from what we did on Friday, opposite sides are congruent. And so my other argument here, this B to L, is this side that's going to be opposite the side from N to X, so that will also be 18. Because you got a parallelogram there. And then all you got to do to find perimeter, just add up the sides. You got 21, 18, 21, and another 18. Does not matter the order that you add those in, and I'm going to cheat and look. That should be 78 if you add that up. And I don't have any labels or anything there, so it should be 78 units since we don't have any like inches or labels or anything like that. Does anybody have any questions? Okay.